Another one where we have some like terms. So we're going to want to isolate cos x. I would probably move the 1 cos x to this side to get 3 cos x on that side. And then I would take the -4 and add it to the other side. You see that you would get -2. And so getting cos x by itself, I would get -2/3. This question is in radians, so I'm going to find my reference angle. And second cos inverse. And remember, when you're finding your reference angle, especially with cos, super important that you use all positives. So cos inverse of 2/3, 0.841. That's our reference angle. Then according to our cast rule, cos is negative in quadrants 2 and quadrants 3. So I'm going to store this answer as x because I'm going to use it twice. In quadrant 2, you would go pi minus your reference angle. And quadrant 3, you would go pi plus your reference angle. So 2.30 and 3.98. Does it say what they want us to round to? Nearest 100. So that's good. 2.30. I forgot the other one already. 3.98. I'm just making a note. I still solve between 0 and 2 pi, like normal. Okay? In this case, we have to check our domain in the end. They want to go from -pi/2 to 3 pi/2. Thinking about that, I always break it up with 0. So if it's going to positive 3 pi/2, can you see that that's looking for angles here? And having the -pi/2 says also look for angles going this way. We wrote down 2 answers. This one happened to be in quadrant 2. This one happened to be in quadrant 3. Should I include my positive one in quadrant 2? Yes. Should I include my positive one in quadrant 3? Yes. Quadrant 4, even though they're negative, doesn't actually come into play. Because cos isn't in quadrant 4 in this situation. But it's going to be something you always have to check. I solved first between 0 and 2 pi. Then what was the domain they were asking for? Do I have to change any of them? Sometimes you'll have to X one out and write a coterminal angle instead. Now you have your answers between 0 and 2 pi. Then we can write the general solution. Take both of your answers, add 2k pi. Then for part B, now we're back in degrees. You're going to find the grade 12 course does this. You're going to be writing your test, have to change your calculator to degrees, then to radians, then back to degrees, then back to radians, back and forth. So in this question, we have √2 cosecant equals -5. So I can get that cosecant x by itself. And I get -5 divided by the square root of 2, which means if I know cosecant, I can flip the ratio, keep the angle the same, and I would get -√2/5. Obviously, this is not on our unit circle, so we're going to have to find a reference angle, but this time when we go to our calculator, we have to hit the mode button, and change back to degrees. Find my reference angle by going sine inverse of the positive. 5 divided by the square root of 2. Oh, and what did I do? No, I wrote it wrong. Try again. Sine inverse of square root of 2 divided by 5. And 16.4 is our reference angle. How much do they want us to round to? The nearest degree. Oh, they're making our life easy. So our reference angle is 16 degrees. And sine is negative in quadrant 3. So we would get 196 degrees, and quadrant 4, 360 minus, again, just make a note. I initially solved between 0 and 360. Is this what they want? No. What did they want? They wanted positive angles up to 180 and negative angles up to negative 180. Can you see that this is a quadrant 3 answer? We're going to have to put an X through it. And instead, if my reference angle is 16, can you see that this is the same as negative 164 degrees? Same thing with the one in quadrant 4. We can't have a positive angle in quadrant 4. Instead, I would have negative 16 degrees. Does it ask for the general solution? It does. Now again, your textbook might use the new negative ones. My personal preference is to go back and use the positive ones. And since this is in degrees, we have to use the 360 degrees times K. Circle questions 6 and 7.